Hello students, and today we are going to solve a very important question on the chapter 3-dimensional geometry. So our question goes on like that. Let n be the foot of the perpendicular from the point P whose coordinates are 1, minus 2, 3 on the line passing through the points 4, 5, 8 and 1, minus 7, 5. Then the distance of n from the plane 2x minus 2y plus z plus 5 equals to 0 is option number A is 6, B is 8, C is 7 and D is 9. So let's start to solve this question. Now, before going further in this type of questions, you have to first of all visualize what the question is really going to ask, right? So first of all, let's make the diagram, and after that we can visualize the question very easily, okay? So let n be the foot of the perpendicular from the point P. Okay, so there is 2 points. The first point is point P and the another is n, which is the foot of the perpendicular on the another line whose 2 coordinates are already given in the question, right? So let's draw that. Now we can see that we have drawn 2 lines. Okay, so the first is the foot of the perpendicular, that is the foot of the perpendicular. So the coordinates of this is, we don't know, we have to calculate it first of all, and the name of this coordinate is n, right? And that is m, whose coordinate is given in the question. You can write it here, that is 1, minus 2, 3. So just write it. And it is also given that lower line on which that foot of the perpendicular is dropping, coordinates of the point through which that line is passing is already given in the question. So let's write it like that, that is 4, 5, 8. So just write it, that is 4, 5, 8. And another point that is given, that is this, that is 1, minus 7, 5, right? 1, minus 7, 5. That is also given. Now, before going further in the question, we have to write the equation of that line. I am talking about this line. So we have to just write the equation of that line because we have already know the coordinates of the 2 points, right? So we can easily write the parametric equation of a line on the basis of that. So let's do that. So equation would be, let's name it like, let's take it as AB. Okay, the name of these points are A and B. So the equation of the line would be x minus the first point, that is 4. What is the point? What is the x coordinate of the first point? That is 4. So that is x minus 4, right? And after that we have to just find the direction ratio. Always keep that thing in mind. In parametric form of equation of line, the lower part is the direction ratio, right? So for direction ratio, that is 4 minus 1, you have to just do the subtraction of the corresponding coordinate. So 4 minus 1, that is equals to 3. So just write it, 4 minus 1. Now similarly in the y part also, what is the coordinate of y in the first point? That is 5. So that would be 5 minus 5. And what would be the direction ratios? What is the y coordinates of the both of these points? That is 5 and minus 7. So what is the difference between 5 and minus 7? You can write it like that, 5 minus of minus 7, right? And after that you have to do the same process with the z coordinate also. So z minus, what is the z coordinate? That is 8. So that is z minus 8 upon just the difference of the corresponding z coordinates, that would be 8 minus 5, right? So just simplify it further. In the numerator section, just write as it is, that is x minus 4. So x minus 4. In the lower part, 4 minus 1, we know that is 3. And after that we have y minus 5. So we'll just write y minus 5. And what is 5 minus of minus 7? We know that minus minus is plus. So 5 plus 7, that is equals to simple 12, right? And after that we have again z minus 8 upon 8 minus 5, that is equals to 3, right? So let's write it like that, z minus 8 upon 3. So that's our required equation of line passing through the points A and B. Okay, now let's move on to the next part of our solution. Let's assume that we don't know the point n now. So let's assume that the whole equation of line, because we know that point n is also lying on that equation of line, that is x minus 4 upon 3, y minus 5 upon 12 is equals to z minus 8 upon 3. So for that purpose we have to just assume that is equals to lambda. Now just equate each coordinates with lambda to get the corresponding coordinate. So first of all, x minus 4 upon 3, just equate with lambda, that will become x equals to 3 lambda plus 4, right? You can see it in the previous slide. We have x equals to 3 lambda plus 4. 3 would be multiplied with lambda, and minus 4 after shifting towards right hand side, that would become plus 4. Similarly, you have to do the same concept. You have to use the same process with y and z also. So I'm just directly writing the y coordinates. So similarly, using the same process, y would be, that is 12 lambda plus 5. And similarly, you have to write the z coordinate also. So for that part, the z would be, you can just see the previous one. So z would be, that is 3 lambda plus 8. So that is 3 lambda plus 8. You have to just simultaneously equate the corresponding coordinates with lambda, right? So that would be 3 lambda plus 8. Now just write in the coordinate form, because we have gotten the x, y and z coordinates. So just write it like that in the coordinate form. So that would become x is 3 lambda plus 4. y is 12 lambda plus 5 and z is 3 lambda plus 8. Am I right? Now let's move on to the next part. We know that you can see the previous figure that we have drawn in the previous part. You can see that PN, line PN and line AB both are perpendicular to each other, right? So for that purpose, we know that when two lines are perpendicular to each other, then their direction ratios, the product of their direction ratios, I mean the dot product, not cross product, the dot product would always be a 0, right? So we have already gotten the direction ratios of our line AB, that is 3, 12 and 3. You can see that the lower part is always called or regarded as the direction ratio of that particular line, and we also know the direction ratio of PN. We know that we have to just do the subtraction of the coordinates of N and P. Okay, so let's calculate our direction ratios of line PN. So we'll write direction ratios of PN. You have to just subtract the corresponding coordinates. We already know the coordinate of P, it is given in the question, and we have gotten the coordinate of N also. You can see that that is our N coordinate. So just do the subtraction of both of these coordinates. So let's do that. So 3 lambda plus 4, that is the x coordinate, and what is the x coordinate of point P? That is, you can see that we have 1. So we'll just write it 3 lambda plus 4 minus 1. Am I right? We are writing the direction ratio. Direction ratio would be written in the vector form. So that is Pn. So 3 lambda plus 4 minus I. Now similarly do with the y coordinate for the j cap. So that would become plus 12 lambda plus 5. You can see it here, 12 lambda plus 5. So 12 lambda plus 5, and what is the y coordinate? That is minus 2. So minus minus is plus now. So I am just directly writing it here. That is 12 lambda plus 5 plus 2. And that is our j cap. And after that we have to do the same process, use the same process with the k cap also. That is the k coordinate, or you can say that the z coordinate, right? So what is the z coordinate of our vector n? That is 3 lambda plus 8. So 3 lambda plus 8 minus what is the coordinate of z in point P? That is 3 now. So just write it 3 minus 3, and that is our k cap. Now let's simplify it further. So that would become 3 lambda plus 4 minus 1. 4 minus 1, that is 3. So we can write it like that, 3 lambda plus 3, right, I cap, plus, let's simplify the second part also. We have 12 lambda plus 5 plus 2. So 12 lambda plus 5 plus 2 would be what? That is 12 lambda plus 7, right? So we'll write 12 lambda plus 7, and that is our j cap, right? Now after that we have to do the same process with the third part also. So 3 lambda plus 8 minus 3. 8 minus 3 is 5. So that would become 3 lambda plus 5. And that is our k cap. So finally we have gotten the direction ratios of Pn also. Pn is what? Pn is the line which is perpendicular. See the figure, Pn is the line which is perpendicular to the what? The line AB. And we know that when two lines are perpendicular to each other, then the product, then the dot product of the direction ratios of both of these lines would be equals to 0. And we know that when we are doing the dot product of two vectors, we have to just multiply the corresponding I cap. I mean to say, you have to just multiply the corresponding x coordinates, y coordinates and z coordinates to get the value of your respective variable. In that case we have lambda. Okay, so let's do that. So we have 3 lambda plus 3. So let's multiply it. So we'll write it here. So Pn dot AB would be equals to 0. So just write it, Pn, direction ratio of the line Pn dot AB, that is the line on which the perpendicular, foot of the perpendicular is dropping. So that will be equals to 0. Now just multiply the corresponding coordinate. So let's concentrate on that part. Tell me what is the coordinate of the point Pn. We know that 3 lambda plus 3. So just write it here, 3 lambda plus 3. In bracket we have to write it like that, 3 lambda plus 3 multiply by what is the next coordinate? What is the next coordinate that we have of line AB? The corresponding coordinate of the line AB, that is direction ratio. What is this? That is 3 now. I have already highlighted it. Just see the lower part. So that is 3. So that is multiply by 3 plus. Now just do the same process with the y coordinates also. Tell me what is the y coordinate of our line Pn. That is 12 lambda plus 7. You can see it here. So just write it, 12 lambda plus 7 here. And what is the y coordinate of our, or the direction ratios of the line AB? That is 12. You can see it here. So just write 12 here. So that will become 12 plus, just do the same process with the third part, that is z coordinate, that is 3 lambda plus 5 here. So just write it, 3 lambda plus 5 in bracket, 3 lambda plus 5 and that would be multiplied with what? What is the z coordinate of our direction ratio of our line? That is 3. So just write 3. And the value of all that would be equals to 0. Now let's do it further. So let's multiply it. So that would become 3 3 j 9. Open the bracket. So that would become 9 lambda plus 3 3 j 9. And similarly in the second part, 12 lambda multiplied by 12, that is 144 lambda, and 12 multiplied by 7, that is equals to 84. And after that, just do the same part for the third one. 3 into 3 lambda, that is 9 lambda, plus 5 multiplied by 3, that is equals to 15, and that is equals to 0. Now just equate it further, just simplify it further. So 9 lambda plus 144 lambda plus 9 lambda, that is equals to 162. So I am just directly writing it here, that is 162 lambda plus, so 9, 84 and plus 15, that is equals to what? That is 108. So that is 108, and that is equals to 0, right? Now just simplify it further. After shifting 108 from left hand side to right hand side, that will become minus 108, and the value of lambda eventually will get, that is lambda is equals to minus 108 upon 162, right? And we can see that both numerator and the denominator are the common multiples of 2, so we can simplify that fraction further. So after simplifying, I am just directly writing it here. You will get minus 2 by 3. You have to just simplify that fraction. So finally we have gotten the value of lambda, that is equals to what? That is minus 2 by 3. So that's the first thing that we have done here. What we have done till now, first of all, we have calculated the direction ratios of both the lines, and after that we have just done the dot product of both of these vectors and gotten the value of lambda. Now just put that value in our point n to get the exact coordinates, right? So our point n was what? Just see the previous part. The point n was what? That is 3 lambda plus 4 and 12 lambda plus 5 and 3 lambda plus 8. So just put these values in place of lambda. Okay, so we'll write, so n would be, you have to just put these values. Now just see it again. We have n as, that is 3 lambda plus 4. So in place of 3, what is lambda? That is minus 2 upon 3. So minus 2 upon 3 plus 4 na, so that is 4. And after that, just do the same thing with the y coordinate and the z coordinate also. So I'm just writing the another coordinate directly. You will get minus 3 and 6 here. You can check it. 3 cancelled by 3, so we would get minus 2 plus 4. So the final coordinate of n would be 2 comma minus 3 comma, that is 6. Right? So that's the thing that we have done in that question. Now we have gotten the coordinate of n, but the question is asking totally different thing. We don't have to calculate the coordinate of n. Here we have to calculate the distance of that particular point n from the plane, and that is very easy. For that purpose, we have to see the very important slide that I have already written it for you. That is the very important formula that we have to use here. That distance between a point and a plane, that is the formula that can be used to calculate the distance between a point and a particular plane. Okay, so that's the direct formula. We have the point x naught comma y naught comma z naught, and the equation of plane is ax plus by plus cz plus d equals to 0. Now we have to just put these values in that formula to get the value of distance. Okay, so let's do that. So distance would be modulus of, in the numerator part we have modulus, and we'll just put the value 2 multiplied by, what is the equation of plane? Just see it here. We have 2x minus 2y plus z plus 5 equals to 0. So just write it like that. And what is the coordinate of point n? In place of x, y, z, you have to just put these coordinates. Okay, so I am writing it. So 2 multiplied by 2 minus 2 multiplied by minus 3, and last, that is 5. Modulus closed. And in the lower part, you have to just do the square root of squares of the coefficient of x, y and z in the given equation of plane. So what is the coefficient of x? That is, just see your equation of plane, that is 2x minus 2y plus z plus 5 equals to 0. So what is the square of 2? That is 4. So that is 4 plus, what is the square of y? That is 2. That is again 4. And what is the coefficient of z? That is 1. So the square of 1 is 1 itself. Now let's simplify it further. So that would become, in the numerator part, 2 to the 4, and that is minus 2 multiplied by minus 3, that is equals to plus 6 plus 5. And what is 4 plus 4 plus 1? 4 4 8, 8 plus 1 9, and square root of 9 is what? We know that, that is 3. Now let's do it further. We have 4 plus 6, that is 10 plus 6, that is 16 plus 5, that is 21. So 21 upon 3. So 21 upon 3, that is equals to 7 units. So finally we have gotten the distance of point n from the plane that is given in the question. So you can see it here. So option number C is the right option. That option is the right option. So let's summarize what we have done in the whole question. First of all, you have to write the equation of line AB. whose two coordinates are already given in the question, and after writing it here you have to just concentrate on the direction ratio part. And similarly now we have to just find the coordinate of n, because we know that that point n is also lying on the line passing through a and b, right? So just assume that the whole equation, parametric equation, is equals to lambda, and on the basis of that just equate all x coordinate, y coordinate and the z coordinate with lambda to get the corresponding x, y and z coordinate of point n. And after getting the coordinate of n, you have to just do the subtraction to get the direction ratio. Always keep that thing in mind. For direction ratio you have to just do the subtraction of two coordinates, that's it. And after getting the two coordinates, we have gotten direction ratios, and after getting the direction ratios of both of these lines, we have to just do the dot product. And we know that when two lines are perpendicular to each other, so in that case their direction ratios product would also be equals to 0, right? So using the same concept, we have calculated the value of lambda, that is -2/3, and after that we have just put this value in our n coordinate that we have written on the basis of lambda. And after putting it, we have gotten the exact coordinate of n, but the question is not asking that. We have to calculate the distance of that point n from the given plane. So for that purpose you have to use the very important formula that I have already written. So you have to just put the coordinates of n that we have gotten in the place of x, y and z in our given plane equation, and after that you have to just simplify it further, and you will finally get the answer, that is the distance whose value is 7 units, and that's your answer. So thank you very much.